Hello friends, I am Prashant and welcome to my second video of concurrency playlist, Introduction to Concurrency. So today we are going to discuss Java concurrency, that is a foundation for multi-threaded programming in Java. Why concurrency? Understanding the need for concurrent programming. The need for concurrent programming is for maximum CPU utilization, handling multiple tasks simultaneously, improving application responsiveness, and the real world examples are web servers handling multiple requests, real world applications like stock trading systems. So why concurrency is crucial in modern applications? Concurrency allows application to perform multiple tasks simultaneously, which is critical in modern software systems for several reasons. The first reason we have already gone through, the maximum CPU utilization. Modern CPU are multi-cores and concurrency enables application to use all available cores effectively. Without concurrency, a single threaded application can leave cores idle, wasting computational power. For example, a video processing application can divide a video into multiple chunks and process each chunk on a separate core. It's significantly speeding up the task. Improving responsiveness. Concurrency ensures that the critical tasks are not delayed by a long running operations. Applications can remain responsive to user input while performing the background tasks. For example, in an in a mobile application, fetching data from a server in the background ensure that the UI remains responsive to the user actions. Third one is handling multiple tasks simultaneously. Many modern applications need to handle numerous tasks or requests at once. Concurrency enables efficient management of these tasks without blocking others. For example, a web server can serve thousands of client requests concurrently instead of processing them one by one. Fourth reason is scalability in distributed systems. Concurrency is foundational for building scalable and distributed systems. It helps distributed workloads effectively different machines or services. For example, a cloud-based microservices architecture use concurrency to process millions of transactions simultaneously. The example is the UPI system in India. The real-world use cases are stock trading systems, real-time price updates and simultaneous trading executions, gaming applications, rendering graphics and processing user input concurrently, IoT system managing data streams for multiple sensors in real time, AI/ML workload, parallel processing of data for trained models. So, concurrency is essential for improving performance, responsiveness, and scalability in modern applications. By leveraging concurrent programming, developers can create efficient and user friendly systems that cater to the demands of today's multi core and distributed computing environments. Threads in Java, the foundation of multi-threaded programming. Thread is the smallest unit of execution within a process. The Java thread model, single-threaded versus multi-threaded. By default, our Java application is single-threaded where the execution used to happen from the main method. And in the multi-threaded application or for creating the multi-threaded application, we need either the implementation of thread that will execute parallelly to the main thread or the supporting classes like Executor service or fork join and others. Basic operations are creating the thread, starting them and stopping the thread. The concept of threads and their basic uses. So what is a thread? Thread is a smallest unit of execution within a process. The process can contain multiple threads, each executing independently but sharing the same memory space. Why threads? For the parallelism. Perform multiple tasks simultaneously to speed up the execution. Resource sharing. Threads share the same memory and resources, making communication between them faster than between the processes. How thread works in Java? So thread creation. So thread can be created by two ways. Either we can extend the thread class, or we can create a runnable, and that runnable will be the part of the thread. So we can implement the thread, and we can check that how can we create it. We will be having two packages, or one package like thread creation, and in the thread creation we will be having one separate package by extending thread. So here we can create a class custom thread. So custom thread will be extending to the thread, and let me bring down the package so it will be visible. And here after the thread we will be overriding the method, the runnable or run, sorry, the run method. So in the run method we can simply write creating the thread dot current thread dot get name by extending the thread. So for we will be needing another class, or we can use the same class and create a main method. So for clarity I can write it down here, the main method, and can show it thread, and this will be actually a thread, and we can call the method like custom.run start. So run will be actually calling in the same main same thread that will be main. When we call the start, it will fork a new thread and it will run that. So let's run this code and let's see what is output. So we can see that creating the thread 0 by extending the thread. So we can create another interface, another package by runnable interface. So we will be creating a new class that will be custom runnable. In the custom runnable, we will be first implementing the runnable interface, and we will be implementing the method run. So we can write it down, creating the thread by using the runnable interface, and here we can add the thread that will be thread.current thread.getName. we will be having a main method where we will create a runnable here, and it will be a new custom runnable, and we will be having a thread is equal to new thread, and we will be passing that runnable inside it, and we will start that this thread. So we are expecting the output creating the thread name by using the runnable interface. So let's run it. Creating the thread 0 by using the runnable interface. Thread lifecycle. Understanding thread states and transition. So while using the thread, it is having multiple states. While we create it, we start it, we stop it, or we end it, or it might be in the waiting state or blocked. So this state, we will go one by one about the state, and we will have the explanation for each state, and we will also see in the code example that when the state actually changes from the set of statement we are going to write. Okay, so the first state is new or created. The thread object is created but not started. So this particular statement happens when we are writing a thread is equal to new thread. At this point of time, we have just created a thread, but we have not started it, or we have not requested to started it. So once the thread is created and we call a dot start method on it, so at this point of time, we are waiting for the CPU scheduler to allocate the resources to this particular thread. So this is the runnable state. Runnable state is when we call the start method and we are waiting the CPU scheduler to allocate time to this particular thread. And when it gets the CPU, when or CPU allocate select this particular thread and execute it, at that point of time the thread came into the running state. From the running state, either thread will be blocked. It can block because of the multiple reasons like input output operation, or once the execution is done, it can go to the terminated. One more thing that is important to remember is from the running state, apart from the block state, we can have multiple states as well. For example, we can have the waiting state or timed waiting state. So from the blocking or waiting state, again the thread can change its state to a runnable, and once it gets the CPU, it starts running again, and when the execution is completed, the thread becomes terminated. So let's go into and once the thread is terminated, the thread actually completes its task, and uh, it is it is stopped. So once it is done, we cannot use the thread to start it again. So let's see in the code example, and we can understand it. So let me move these two packages into the beginner one. So by extending thread, custom thread is refactor. Yeah, okay, it is done. So next code we are going to write for the package thread states. In the thread state, we are going to write one Java application for simple Java class, and here and write down a main class, and we are having a thread is equal to new thread, and we are writing one runnable here, and runnable is doing nothing but running the thread. That name. And at this point of time when we are doing it, it is in a new state, new or create state. Once we start the thread, at this point of time we are requesting CPU to execute it. So in this particular state it is runnable. When the thread is printing this output, in this case it is in the running state, and once it is done, when we are having this output and thread is done its job, we come to the last stage, that is terminated. Apart from that, if we are having a method like public void show blocked state, we are having one object and we are using synchronized, and we are using this particular object, or we can write it down the lock, then we can object dot wait. Yeah, in this case it will be needing to throw the exception, interrupted exception. So once we are locking any object, at that point of time as well, this particular thread is going into the blocked state. Let me show through the complete program. So yeah, here we are having main and we are having this, so blocked state. So here we will be having a blocked state when we are blocking this particular object, or we can write it down like lock. Thread creation in Java. How to create and manage threads. The thread creation, as we already discussed, we can create thread by two ways. Either we can extend a thread and we override the run method. So when we will create the instance of that thread and we will call start method, at that point of time the run method will execute. In the runnable implements runnable approach, we will create one runnable, we will implement the runnable interface, and we have to override, or we have to implement that run method. And whenever we will create the thread, we will pass the runnable object inside it in the thread constructor, and we will call the start method. In that way we will be having a thread execution using implements runnable. So yeah, here are the way we can do that. So here we are having a custom thread, we are extending that thread, and we are overriding run method here, and we will be creating the instance of that custom thread. We will call the start method that will run a thread into um, into a new, it will execute this particular run method into a separate stack. While using the implements runnable approach, we will having a class, it will implement the runnable, it will override the run method, and yeah, it is mandatory, and we will create this runnable instance of it in the thread uh, parameter, or into the while creating the constructor of that thread, we will pass the runnable and we will call the start method. In that way we will be having this thread creation implements runnable thread, we will be having this as an output. Synchronization basics, managing thread safety with synchronization. What is synchronization? Synchronization is a mechanism to control access to shared resources by multiple threads. So, if multiple threads are trying to access one single resource, then synchronization helps us managing or control access to that particular resource. It ensures thread safety by preventing simultaneous access that could lead to data corruption or inconsistent states. Using synchronized blocks and methods. There are multiple synchronized blocks and methods are present. For example, in case of method, we are having the synchronized keyword is used either with the method or with the static method. So these are two places it can be used. We can use a synchronized block where the synchronized block we will be having object, because every object uh, having a lock, so we can pass the object inside it and we can keep the critical section inside that particular synchronized object block. Apart from that, we can use the volatile variable, so it ensures visibility of the changes to the variables across threads, but it does not enforce atomicity. So now look at the example of counter increment with and without synchronization. So in the intermediate, I am creating one package that is counter synchronization. Here I am creating a counter class. In the counter class, we will be having a private int counter variable. We will be having a public method that will increment this counter, and we will be having a function to get the counter value. Look at this method. When we are incrementing, it is not thread safe. So when multiple threads will try to increment the counter, it is possible that the number just increment by 1 from 2 to 3, while two threads are trying to increment it, and when the synchronized block is there, it is supposed to be incremented by one after another. So let's create a counter example. Here in this example, we will create two threads, and two threads will sharing this counter variable, and both will try to increment number by 1 million, and other will also try to create increment the counter variable by 1 million, and it is supposed to be 2 million, but let's see what we get. So in the main method, we are creating a counter variable. We will be having two thread 1 is equal to new thread. We will be having a runnable method. This runnable method will be containing the counter, and there will be two threads, and we will start them, but before that let me implement the get runnable method. So we are going to return runnable is in this format, so it does not take anything, it does not return anything. So here we will be incrementing this counter by 1 million, so it is 1 million. We will be having this counter variable and we will increment it. So both threads will increment it 1 million times each, so it is supposed to be 2 million after we start the thread. Also, we also want the completion of both of these methods, so we will call the join method. So we will be having illegal uh, interpreted exception e, and once these two threads are executed, we will print the value of counter variable. So let's run it without the synchronize keyword. Let's see what is the output. So it is 1,80,000. So it will be it is supposed to be 2 million, but it is 1.8 million. So let's go to the counter variable and counter class and just write it down, synchronized this particular increment. So whenever this method will be called, each thread has to take the log first before entering it. Only one thread can enter it. So this value supposed to be changed to 2 million. Let's run this again. Voila, 2 million. So here we are, we have seen this counter example, and now about the role of the synchronization in managing thread safety. So first of all, it protects the shared resources. As we have seen, it ensures only one thread access the critical section at a time. It eliminates the race condition, prevents conflicting update to a shared variable, and it maintains the consistency. Thread communication, enabling coordination between threads. When multiple threads are executing, they can coordinate with each other by using the signals like wait, notify, and notifyAll. About wait, these methods and regarding wait, notify, and notifyAll, all these methods belongs to the object class. These are used to coordinate threads and they must be called inside a synchronized block or method. Regarding the wait method, it causes the current thread to release the lock and wait until another thread calls notify or notifyAll on the same object. Notify method, it wakes up one waiting thread. The awakened thread can resume execution when it regains the lock. The notifyAll awakens all the waiting threads and they compete to get the CPU and resume their execution. One standard problem for the thread communication is producer consumer problem that we are going to implement in the upcoming videos. So basic thread communication mechanism is wait, notify, and notifyAll when we use the object or look object. And the advanced way of doing that, we create a instance of lock object, and the implementation of that we can use the reentrant lock, and we can use that particular object to lock and unlock to a particular section where we will execute the code that is the part of the critical section. Apart from that, we will also use the object of condition condition class that will be on the lock object, and we can use the equivalent method of wait and notify, like wait and signal to awaken the other method, other threads. High level concurrency APIs, glimpse into advanced tool and abstractions. So these topics we are going to cover in the advanced module that will cover the executor service, callable and future, logs, and highlight their role in the simplifying concurrency, their code implementations, and apart from that we will also cover the fork join and related stuff. So friends, if you learned something new in this video, please don't forget to like this video, subscribe to my channel and hit the notification bell so you never miss an update. Share this playlist with your friends or colleagues so it just be the as they need. So let's dive into the fascinating world of Java concurrency one step at a time. See you in the next video.